Hey guys, Game Dev Coach here. In this video I'll go over what game engines are. If you are new to my channel, please do well to subscribe because I make weekly game development videos and you don't want to miss out on them. Also leave me a like and a comment down below if you like this video. Okay, now back to the video. What is a game engine? Before we dive in and take a look at what game engines are, let's talk about what a game is. We probably all have a pretty good intuitive notion of what a game is. The general term game encompasses board games like chess and Monopoly, card games like poker and blackjack, casino games like roulette and slot machines, military war games, computer games, various kinds of play among children, and the list goes on. In academia we sometimes speak of game theory, in which multiple agents select strategies and tactics in order to maximize their gains within the framework of a well-defined set of game rules. When used in the context of console or computer-based entertainment, the word game usually conjures images of a three-dimensional virtual world featuring a humanoid, animal or vehicle as the main character under player control. Or for the old geezers among us, perhaps it brings to mind images of two-dimensional classics like Pong, Pac-Man, or Donkey Kong. In his excellent book, A Theory of Fun for Game Design, Rafe Koster defines a game to be an interactive experience that provides the player with an increasingly challenging sequence of patterns which he or she learns and eventually masters. Koster's assertion is that the activities of learning and mastering are at the heart of what we call fun, just as a joke becomes funny at the moment we get it by recognizing the pattern. For the purposes of this video, we'll focus on the subset of games that comprise 2- and 3-dimensional virtual worlds with a small number of players, between 1 and 16 or thereabouts. The term game engine arose in the mid-1990s in reference to first-person shooter, FPS, games like the insanely popular Doom by ID Software. Doom was architected with a reasonably well-defined separation between its core software components, such as the three-dimensional graphics rendering system, the collision detection system or the audio system, and the art assets, game worlds, and rules of play that comprised the player's gaming experience. The value of this separation became evident as developers began licensing games and retooling them into new products by creating new art, world layouts, weapons, characters, vehicles, and game rules with only minimal changes to the engine software. This marked the birth of the mod community, a group of individual gamers and small independent studios that built new games by modifying existing games, using free toolkits provided by the original developers. Towards the end of the 1990s, some games like Quake 3 Arena and Unreal were designed with reuse and modding in mind. Engines were made highly customizable via scripting languages like ID's Quake C, and engine licensing began to be a viable secondary revenue stream for the developers who created them. Today, game developers can license a game engine and reuse significant portions of its key software components in order to build games. While this practice still involves considerable investment in custom software engineering, it can be much more economical than developing all of the core engine components in-house. The line between a game and its engine is often blurry. Some engines make a reasonably clear distinction, while others make almost no attempt to separate the two. In one game, the rendering code might know specifically how to draw an orc. In another game, the rendering engine might provide general-purpose material and shading facilities, and orcness might be defined entirely in data. No studio makes a perfectly clear separation between the game and the engine, which is understandable considering that the definitions of these two components often shift as the game's design solidifies. Arguably, a data-driven architecture is what differentiates a game engine from a piece of software that is a game but not an engine. When a game contains hard-coded logic or game rules, or employs special case code to render specific types of game objects, it becomes difficult or impossible to reuse that software to make a different game. We should probably reserve the term game engine for software that is extensible and can be used as the foundation for many different games without major modification. Clearly, this is not a black and white distinction. We can think of a gamut of reusability onto which every engine falls. One would think that a game engine could be something akin to Apple QuickTime or Microsoft Windows Media Player, a general-purpose piece of software capable of playing virtually any game content imaginable. However, this ideal has not yet been achieved, and may never be. Most game engines are carefully crafted and fine-tuned to run a particular game on a particular hardware platform. And even the most general-purpose multi-platform engines are really only suitable for building games in one particular genre, such as first-person shooters or racing games. It's safe to say that the more general-purpose a game engine or middleware component is, the less optimal it is for running a particular game on a particular platform. This phenomenon occurs because designing any efficient piece of software invariably entails making trade-offs, and those trade-offs are based on assumptions about how the software will be used or about the target hardware on which it will run. For example, a rendering engine that was designed to handle intimate indoor environments probably won't be very good at rendering vast outdoor environments. The indoor engine might use a binary space partitioning, BSP, tree or portal system to ensure that no geometry is drawn that is being occluded by walls or objects that are closer to the camera. The outdoor engine, on the other hand, might use a less exact occlusion mechanism, or none at all, but it probably makes aggressive use of level of detail (LOD) techniques to ensure that distant objects are rendered with a minimum number of triangles, while using high-resolution triangle meshes for geometry that is close to the camera. The advent of ever faster computer hardware and specialized graphics cards, along with ever more efficient rendering algorithms and data structures, is beginning to soften the differences between the graphics engines of different genres. It is now possible to use a first-person shooter engine to build a strategy game, for example. However, the trade-off between generality and optimality still exists. A game can always be made more impressive by fine-tuning the engine to the specific requirements and constraints of a particular game or hardware platform. Thanks for watching the video to the end. Comment down below what video you want me to make next, and feel free to connect with me on Instagram and Twitter. All links are available in the description below. Love you, peace.